Okay, now we're moving on to the demonstration of how to produce a cross-section. So the first thing we need to do is add the cross-section toolbox. So you can go, if you click on the ArcToolbox symbol, and we want to just right-click anywhere in space and add the toolbox. And then you have to go move into the folder where you've downloaded things and go into downloads and just keep drilling, and at some point you'll get to this level here, which shows a number of folders, and then cross-section tools .tbx. So this is the toolbox that has all the elements that are needed to produce a cross-section from this map data and the topography. So just say open, and then you see the toolbox is there with its portions, the tools ready to go. And so this is a cross-section toolbox that was produced by Evan Toms at the U.S. Geological Survey, and so we're grateful for the chance to use it. One important thing to realize is that you have to add the toolbox every time. It doesn't stay. But before we proceed further, we need to actually get the cross-section in the right place. So one thing is important to realize: we have two different sets of layers. We want to activate the geologic map. And then if we zoom out a bit, we'll see that the cross-section's down here, but at least for now, we want to move that cross-section to the area of interest. So my demo, I need it up where my data are. You may want to move your cross-section around as well. So the easiest thing to do then is if you go to Editor, Start Editing, go ahead and pick cross-section A, and then if you use your selection tool, I was having a hard time grabbing it, and I'm not exactly sure why. So the easiest thing to do is select by location, click on the X section A target layer, and apply. And so then you see our layer is, the cross-section is now selected, and if you lose it, you can just do the same thing. So say if I click like this, I just say, oh, okay, let me grab it again. Okay, so keep that open. I'll move it up here, and then I realize, well, I need to change the orientation. So if I right-click, I can get Edit Vertices, and that'll let me grab this corner here, the other end there, and I want to move it near to where I have some strike and dips in this case, and also roughly perpendicular to the strike and dip, so the apparent dip isn't too much of a problem. So now if I click like this, it's there, and I'm ready to proceed. Okay, now we've got things in place. Let's try to at least get the segmented surface profiles, get the hard part of the topography and transferring the contacts done. We can actually move our profile down just a little so I get this diagram right in there. Okay, so let's say we're ready to make our cross section. So let's go to the data view and make sure that the geologic map layers are activated. Now, one important thing that'll save you some trouble is make sure that the editor, that everything, you're not editing. This is a key thing. If you get an error, that's because the editor you were in a edit mode, and so it would say stop editing. So make sure that's stopped. Now then, we'll just go over here to our toolbox, and then you see, oh, okay, we don't have the cross section, so let's add it. To navigate to it, and remember, it's going to be in Downloads, Cross Section Master. Get this guy. So now when we open this, we can say Create Segmented Surface Profile. So we want to make sure everything is done just exactly the right way in here. Let's say the cross-section line is A. DEM layer is the Arnett Creek DEM. Let's just leave this here northwest. The geology poly layer should be the map unit polys. Vertical exaggeration is 1. Output feature class. So if you already had one there, just make another one, CSA segline 2. And then we want to add this to the data frame, which is the cross-section layers. So let's try it. Now it's going through, it's pulling the elevations out for us, and then it's also it's basically breaking up the profile into segments that are color coded by each of the different polygons, and then we can use that to color code. It may take quite some time. All right, so now we're done. You see it activated the other layer, and the frame is larger because it's kind of used to a longer profile, but that's all right. Let's go to table of contents. We're going to take our CSA segline 2 and right-click properties. We want to click the symbology, and let's import. And if you need to get out of the toolbox here and go back up to your top level, we want to look in the layers folder, and let's get the CSA segline layer, say add, say OK, and then this is important to use just the map unit here, say OK, and say OK. And so now what's quite exciting is you can see the colors in this profile. We have, if we switch to the data view here, or let's switch to the map view. What's really nice is you can go basically polygon by polygon. So you can see right here, this is the first little bit of yellow is the alluvium. Then we go into some colluvium. Then we have a bit of the diorite, then the Pioneer, Dripping Springs, and we keep on going. So this saves you a huge amount of time because A, you have now the topography, and B, you have the intersections. So from here, we're going to go to do it manually to save some time, but you can just print this out and draw the rest. And but it saves a lot of time, and you can do it right on the map. Okay, so now we're turning to analog mode. I printed this on the printer. You can see it pretty much all fits on 2 pages. There's a few other pieces here that printed out that you might try a little bit of scaling when you print. But the main thing is our cross-section is right here. So you can see now I'm just going to basically build my cross-section using the map and the cross-section that we have. So I can measure the strike and dip right now. You can see underneath the ruler I have already drawn what I think might be the alluvium and colluvium contacts. Okay, so I'm not going to draw everything, but you can see here I've got a few things started. I used that strike and dip in the Pioneer, the 85, to give me that contact at the bottom of the Dripping Springs. I drew the Madeira in, and then I have a shallower, sort of 60 degree or 65 degree dip over here in the Dripping Springs. I put some patterning in to show it. So then you would just have to finish your cross-section, do the patterns, the colors, the labeling, but now you just have to do all this interesting geology and less of the mechanics of getting the topography and the contacts in.